Hello everyone, it's Rainer, and today I'm doing the indirect pathway of the brain, and specifically this happens in the basal ganglia, and these are nuclei that are found in the basal ganglia, and we can relate this to Parkinson's. I'll get into that in a bit, but first we start off with the motor cortex. So the motor cortex is going to consist of glutamate that excites the striatum. So as you can see here, when that excites the striatum, it's going to go into these inhibitory, which is the GABA. It will increase inhibition, and when that increases inhibition, it's going to increase inhibition to the globus pallus external. Now, when you hear increase inhibition, it means to slow down the role, and the role of this globus pallus external is to pull back. So it's going to slow down that pulling back of the subthalamic nucleus. Now, when it slows down that pulling back, it's going to fulfill its role of exciting the role of the globus pallus internal, and that role is to pull back. So when it excites that pull, it's going to pull back on the thalamus, therefore resulting in decrease of movement. So that's pretty much what happens overall. However, when we introduce dopamine, which is produced in the substantia nigra, that's gonna go into the D2 receptor, and when it goes into this receptor, it decreases inhibition. So it's going to like kind of speed up a bit. So it's going to kind of a little bit speed up the pulling back of the subthalamic nucleus. Therefore, it kind of has a little bit of it less excites this the role of this. So therefore, it doesn't pull back as much. The GPI doesn't pull back as much in the thalamus. Then therefore, we have a little bit of movement. So all in all, that's why Parkinson's patients need to have that increase of dopamine so that they are able to prevent these freezing episodes, which is that pullback of the thalamus. Because whenever the thalamus pulls back, it decreases movement. But yes.